Hey friends, welcome to NIKRA'S Expert Learning. In today's video, we are going to discuss about the design philosophies that are generally used in the RCC members design. Okay, during the design of an RCC member, we will be having three theories to be followed, and in that, depending upon a requirement and some criteria, we'll be selecting one of this. If you like this video or find this video helpful, guys, please do subscribe to the channel. That would greatly motivate me. And coming to this, we are having three theories as I have told you before. Coming to the first one, we are having working stress method. It is based on elastic theory. See, whenever I am saying elastic theory, the term itself explains. That is, both steel and concrete behave elastically, and the variation of stress is linear. So the stress is varying linearly. This method of design is based on permissible stresses in concrete and steel are not exceeding anywhere. So here whenever we are designing any member under this working stress method, these are the assumptions we follow. And remember, whenever we are designing, we think that whatever the stresses that are developing in this will not be exceeding the permissible stresses. Whatever the allowable stresses are there, that are not exceeded. And the sections are designed as per the elastic theory of bending. We know this. This is a very important and basic theory, elastic theory of bending. And here we are assuming both materials, that is steel and concrete. Here we are discussing about RCC members, that is why we have to mention about the steel and concrete. Okay, here we are assuming both members, the materials obey Hooke's law. We know the Hooke's law, right? The permissible stress is equals to yield stress by factor of safety. Remember, whenever we are analyzing any member, we take the permissible stress as yield stress by the factor of safety. And here the factor of safety for steel is 1.79. The factor of safety for concrete is 3. It is a very important question that can be asked in any competitive exam, guys. Remember, under working stress method, whenever we are asked about the factor of safety of steel and concrete, the values would be this 1.79 and 3 for steel and concrete respectively. Coming to the second method, we are having the ultimate load method. In this method, the stress condition at the state of impending collapse of structure is analyzed. See, remember the word, don't forget this term, guys. Ultimate is itself explaining us that it is at the maximum limit. Okay, it is ready to collapse. So impending collapse of the structure is analyzed. So at that point we are analyzing that. So the concept of modular ratio is avoided in this method. We know the modular ratio is nothing but the ratio of modulus of elasticity of steel to the modulus of elasticity of concrete. So here we are avoiding that concept. The safety measure is introduced in the design as load factor. In this method, we are having some load factor. So the working load is increased by a factor called the load factor. That is 1.5 to obtain the ultimate load. So here we are getting the ultimate load by multiplying the working load with some factor. So this factor is going to be the load factor. Generally we take it as 1.5. Okay, so in the working stress method, we were having some permissible stresses wherein we are dividing the yield stress with the factor of safety to get the permissible stress. And also the factor of safety for steel and concrete are provided. Now, in this ultimate load method, we are developing the ultimate load and the working load relation. So here, to get the ultimate load, we are multiplying the working load with 1.5. This is the load factor. Okay, next, this method takes into account the non-linear behavior of stress in concrete. So whenever there is some non-linear behavior, generally it is avoided in most of the cases. But here we are also considering that behavior. Non-linear is whenever the stress in concrete is not linear. See, even this non-linear part of this concrete is also considered in this ultimate load method. Next, we are having the last method and the most used generally, the limit state method. The acceptable limits of safety and serviceability requirements before failure occurs is called as a limit state. See, here we are talking about the limit state. limit state is nothing but we are providing some limits. Okay, so the acceptable limits of safety and serviceability. So here we are considering two important terms, that is safety and serviceability. Two very important terms. Before failure occurs, whatever from the safety and the serviceability criteria, whatever the limits we are putting to that structure, we call that as limit state. This method is based on the concept of safety at ultimate load and serviceability at working load. Remember, at the ultimate load we are seeing this safety. Okay, so ultimate is it is about to fail. In that case the safety is important. And the working load, that is it is good to go. Here we can put the load. In this case we are checking the serviceability. Okay, ultimate safety. In the working load we are checking the serviceability. Okay, under the working load we are checking the performance, not the safety. But on the ultimate load condition we are checking the safety. A limit state is a state of impending failure beyond which a structure ceases to perform its intended function satisfactorily in terms of either safety and serviceability. Here in the limit state, two important terms or the classification of the limit state is the safety and serviceability. Very important topic, guys. The safety and the serviceability, very important terms. Okay, so there are two types of limit state. That is, as I have told you, we are having the limit state of serviceability, limit state of safety. Okay, so in this we are having the limit state of collapse. Whenever we are saying collapse, it is about to fail. Again, it is under the ultimate limit state. See, the second one was ultimate load method, but here we are having ultimate limit state. Okay, and here it is again classified. The limit state of collapse is classified into limit state of flexure, limit state of shear, and limit state of bond. So whenever we are talking about the ultimate cases, we are talking about this. So generally the flexure or bending is considered, the shear, the bond, that is generally the compression, the torsion, the bending, shear, everything would be coming under this ultimate limit state or limit state of collapse. So generally it is the limit state at which the structure is likely to collapse. Okay, so depending upon these parameters we are analyzing the structure under this case. Under the limit state of collapse we are analyzing the structure based on the following parameters. Next we are having the limit state of serviceability. So as I've already explained you, it is the limit state at which the structure undergoes excessive deflection which affects the finishes, like causing some discomfort to the users, and excessive cracking which affects the appearance of the structure. Okay, whatever the aesthetic appearance or which do not affect the structure, like the structural performance is not affected by but the appearance of the structure is affected. Okay, excessive cracking or deflections or discomfort, whichever is coming, will be under this classification, the limit state of serviceability. So here we can just see the limit state of deflection, cracking, vibration in detail. So generally these are very top 3 picks under the serviceability, but we will also be considering the deflection, cracking, vibration, fire resistance and durability. So all these 5 will be coming under the serviceability. So generally we are having 3, but also the fire resistance and durability are considered in this. In this we are not having the load factor, wherein in the ultimate method we were getting the ultimate load by multiplying the working load with some factor called load factor, that is 1.5. Here we will be having the partial safety factors and the design strength. Okay, so to obtain the design strength of steel and concrete, the yield strength of the steel, that is Fy. So remember, whenever we are saying Fy, that is the yield strength. Okay, and the characteristic strength of concrete, that is FCK, are divided by the suitable factors. So here we are dividing. Okay, in that case we were multiplying to get the ultimate load. For steel, a partial safety factor of 1.15 is recommended by the IS 456-2000 limit state design. So remember, this is as per the IS codal provisions, which are the data I am providing as per the IS code 456-2000. Okay, so here we are dividing this yield strength and characteristic strength of concrete with some suitable factors. we are calling that as partial safety factors. To get the design strength of materials, okay, to get the design strength of steel, we are dividing it with 1.15. See, the design strength of steel is nothing but Fy, the yield strength of steel, divided by 1.15. This is provided by the IS Codal Provision 456. So this will be getting 0.87 Fy. Next, for concrete, a partial safety factor 1.5 is taken twice, that is FCK divided by 1.5 multiplied by 1.5, that is 0.67 FCK by 1.5, that is again 0.446 FCK. Okay, remember, in the limit gate method, the partial safety factors considered for steel is 1.15, for concrete it is 1.5. But in the case of working stress method, it is different. In the working stress method, it was 1.79 and 3. Okay, I think I have explained you everything in detail regarding this design philosophies. I have explained you working stress method, the ultimate load method, and limit gate method. So there is some upcoming series coming, guys. Like we'll be solving some problems regarding this working stress method, the limit gate method in detail, and all the ultimate load method problems will also be discussed. If you like this video or found this video helpful, please do like, share and comment to the channel, and don't forget to subscribe my channel, guys. That would greatly motivate me. Thank you for watching this video.